In the previous lessons, we saw that we could solve a few first-order differential equations by recognizing them as separable, linear, exact, homogeneous, or perhaps even Bernoulli equations. Now, even though the solutions of these equations were in the form of a one-parameter family, this family, with one exception, did not represent the general solutions of a differential equation. Only in the case of linear first-order differential equations were we able to obtain general solutions by paying attention to a certain continuity condition imposed on the coefficients. Now recall that a general solution is a family of solutions defined on some interval, let's call I, and that contains all solutions of the DE that are defined on that said interval I. What's up, guys? And welcome to Differential Equations. For this lesson, our primary goal is to find general solutions of linear higher order DEs. Thus, we first need to examine some of the theory of linear differential equations. But before that, our daily gospel. Let us remember that we are in the holy presence of God. In the name of the Father, the Son, the Holy Spirit. Amen. The scripture for today is from Psalms 103, verse 2. It says, "Let all that I am praise the Lord. May I never forget the good things He has done for me." When hard times come, it's sometimes really easy to want to give up. You might blame God or just give up. In the midst of hard times, it's important that we remember what this verse says. It tells us to praise the Lord and to not forget the good things He has done for us. It's easy when things aren't going the way and you want to give up and blame God and start throwing ourselves a pity party. If we do this, however, we're missing out on something that is really important. God tells us to not forget the good things He's done. When we remember God, when we remember the things He has done for us in the past, we begin to realize that God will help us out this time too. So instead of getting discouraged when tough times come, choose to look to God and remember the times God has brought you out of those bad situations. And realize He will do that again for you. As Lasallians, let us pray. I will continue, O my God, to do all my actions for the love of Thee. Saint John Baptist de La Salle, for us, live Jesus in our hearts forever. In the name of the Father, the Son, the Holy Spirit. Amen. All right. So first, let us discuss some basic concepts before we dig in deeper. We will be tackling about homogeneous second-order linear differential equations, or short SOLDE, with constant coefficients. So far in our discussions, we will notice that there are basically two forms of differential equations. Consider the general form. We mostly encounter differential equations that that have this kind of form: a of x, y double prime, plus b of x, y prime, plus c of x, y equals f of x. You can see here that it is a second order differential equation because of y double prime here, right? Now, we will notice here that the coefficient functions a, b, and c, and f as well are continuous on an open interval I. Now here we assume that the addition, or the addition that a of x is not equal to 0, and at each point of that interval, so we can divide each of the term by a of x and write it as like this. For example, So we can divide the whole equation by the leading term a of x, right? No, and we'll arrive at an expression that will give us y double prime plus b of x over a of x y prime plus c of x all over a of x y equals f of x all over a of x. Okay. Now, we can express and simplify this further if we, let's say, call b, this function here, this coefficient here, b of x over a of x, to be p of x. So if we have y double prime plus p of x, y prime plus, let's call c of x over a of x q of x, y equals small f of x, no? That would represent this whole equation. This factor over here, which is f of x over a of x. Now this equation here, or form of equation here, is actually what we call the standard form. Okay, the standard form. So this is the standard form. And we represent yung ating naging coefficient kanina as seen to be p of x, q of x, and f of x. Now, if f of x, yung ating right-hand side of the equation, is equal to 0, we call this a homogeneous second-order linear differential equation. For us to better understand yung ating topic today, balangkasin natin bawat salita, no? We have here homogeneous solid second-order linear differential equation with constant coefficients. Okay? So we started by first defining what do we mean by homogeneous. Okay? So given our differential equation here with two forms, general form and standard form, if our f of x, which is itong nasa right-hand side of the equation, is equal to 0, we call that a homogeneous differential equation. Now, kung hindi siya equal to 0, that is a non-homogeneous differential equation. Now, don't be confused, all right? Because some of you may ask, teka, di ba in our previous lesson, we defined homogeneous as a function that has the same degree or the same exponent, the same power, no? Actually, a differential equation can be homogeneous in either of the two respects. First, if the coefficients of the differential terms in the first order case could be homogeneous functions of the variables. Yun yung ating tinalakay noong ating previous lessons, which is one of the ways to solve a first order differential equation, right? If they are not separable, we introduce a factor, no, v, and then transform it if it is homogeneous for it to be separable. So yun yung first respect or definition ng ating of what we mean by homogeneous. Pangalawa, for the linear case of any order, meaning from second and above, or any order from 1 to infinity, there could be no constant term in the right-hand side of the equation. Naalala pa yung ating equation kanina, which is yung standard form ng second-order linear differential equation, which is y double prime plus p of x, y prime plus q of x, y equals f of x. If this part here is equal to 0, then we call it homogeneous. No? A homogeneous differential equation. Alright? Now, ano uli? Definition 1, yung ating first order differential equation defined by m of xy plus nxy dy equals to 0. It is homogeneous if m and n are both homogeneous functions of the same degree. We use this again for us to transform the equation and make it separable. So, pang first order yun. Now, for any order, a function is homogeneous. Rather, a differential equation is homogeneous if once all the terms involving the unknown function are collected together on one side of the equation, the other side, and is identically 0. Okay? 0. Yan. So, para hindi natin malimutan, ano? Basta daw yung ating differential equation ay equal to 0. Kaya pa natin, equal to 0. Ayan, siguro by this time, medyo nag-click na kung ano yung homogeneous differential equation. 0. Wag naman 0.0, okay? Now, puntahan naman natin yung pangalawang word, which is second order. If you will recall, the order of the differential equation is the order of the highest derivative in the equation. For example, if we have d squared y over dx squared plus 5 dy over dx raised to 3 minus 4y equals e to dx, the order of the derivative is the one that is expressed here sa gitna ng d at saka ng y. It pertains to the number of times it will be differentiated. So in this case, second order siya kasi twice siya di-differentiate. Now, dito naman, pagka wala namang nakalagay na number, it is considered de facto as a first order. Okay? Again, the order is the order of the highest derivative in the equation. So if this is your whole differential equation, you will notice na ito yung highest, no? So this whole equation here is a second order differential equation. Liwanag? Sana naalala pa. Now, for the next word, linear. What do we mean by linear? The differential equation is said to be linear provided that the dependent variable contains no powers nor functions of y, y prime, and y double prime. If we have our differential equation having a general form of a of x, y double prime, plus b of x, y prime, plus c of x, y equals f of x. Now, unless otherwise noted, we will always assume that the known function, or rather the known coefficient functions, which are if a of x, b of x, c of x, and f of x, are continuous on some interval I on which we wish to solve the dE, but we do not require that they be linear functions of x. Okay? So, again, if we may refresh our memories, how do we determine if a differential equation is linear or not? First, we have to look at the dependent variable, no? The dependent variable. In this case, yung ating dependent variable, if our derivative is dy over dx, this is our dependent variable, and this is our independent variable. Correct? Now, we have to look down for the dependent variable. In this case, that is y. Dapat daw yung ating y contains no powers or even functions of y, y prime, and y double prime. So, in other words, dapat daw yung y raised to 1 lamang. Okay? Because that is how we define a line. Kaya siya linear, di ba? From the root word line. And kapag ka y squared na yan, parabola na yan, hindi na siya line. So, therefore, hindi na siya linear. So, the only thing that will make this linear is that if your y is raised to 1. Ganon din kapag ka yung coefficients noong iyong expression for differential equation should be a function of x only. In other words, kapag may kasama yung y, for example, y and then y double prime, this is already non-linear. Pero as long as it is a function of x, wala ka tayong kaso. Hindi natin yung titignan. That is why, kahit pa sabihin na natin, for example, na cosine x, y double prime, yung coefficient ng ating derivative, ng ating dependent variable, this is still linear, no? Why? Because yung coefficient niya is dependent naman on x. Okay. So, yun yung laging aalalahanin. Una, tignan yung power or order ni y. Pangalawa, tignan yung coefficient ni y. Dapat ang power ni y ay only 1. Dapat yung coefficient ni y rather ay function of x lamang. Otherwise, non-linear na yan. Okay? Now, let us have some exercises and identify the following if they are linear or non-linear. Number 1, we have e to the x, y, double prime, plus cosine x, y prime. So, we have meron pala, 1 plus square root of xy equals inverse tangent x. Okay? Is this linear or non-linear? What do you think? Pause this for a while if you want to guess longer. The answer is that this is linear. Yan. Bakit siya linear? Kasi, if we're going to take a look again at all our y's, y, it is raised to the power of 1, and then yung coefficients niya ay function of x. So, goods tayo doon. Okay? So, pangalawa, we have y double prime plus x squared y prime plus 3 equals x cubed. Is this linear or non-linear? So the answer is it's linear. Bakit? Again, we have to take a look at our dependent variable. In this case, that's y. So y double prime here, raised to the power of 1 naman. Ganun din ito. Which is, so dalawa lang yung y natin. Ito at ito. This one and this one. Now, paano yun, sir? X squared to, tsaka ito x cubed to. Akala ko ba dapat definition niya ay raised to the power of 1? Well, yun nga, dapat ang titignan natin ay yung dependent variable lang, which is, in this case, y. Kaya regardless of whether x is raised to any power that is greater than 1, wala yung kaso. Number 3, y double prime equals y prime. Is this linear or non-linear? Correct. This is non-linear. Bakit? Because of this function. Yan. So, dapat yung coefficient ng ating y prime or even y should be a function of x. Okay? How about number 4? Is this linear or non-linear? This is linear. Tama? This is non-linear. Bakit? Correct. Because of this exponent here, y prime is raised to 2. Ayon. So that made it non-linear. Alright, let's now go to our third or rather last word. Constant coefficients. Ito medyo madali lang to i-distinguish. By constant coefficients, if we have the differential equation as defined or as a differential equation that has a form of a of x y double prime plus b of x y prime plus c of x y equals f of x, it will be homogeneous solde with constant coefficients if yung ating coefficients a of x, b of x, and c of x are constants. Medyo madali namang tandaan, ano? Well, otherwise, the homogeneous second order linear differential equation will have variable coefficients if a of x, b of x, and c of x are not exclusively constant but has a variable. Okay? So pagka exclusively constant siya, constant coefficient siya. Otherwise, variable coefficient siya. Okay? Yeah. So medyo madali lang siyang tandaan. Let's take a look at some exercises for us to further solidify yung ating understanding. So let us identify if the following functions are homogeneous or non-homogeneous, constant coefficient or variable coefficient, linear and non-linear. Alright? So for A, we have quantity 1 minus x squared, y double prime, minus 2xy prime plus 6y equals 0. Is this homogeneous or non-homogeneous? Again, how do we define if a function or if a differential equation is homogeneous? we look at the right-hand side of the equation. In other words, etong part na yan. And we see na itong part na to ay, which is, this one is our f of x. This one is equal to 0. That means na this is correct. This is homogeneous. Now, second, is this constant coefficient or variable coefficient? It's very obvious. Ito yung coefficients ng ating dependent variable. Meron tayong isa ditong coefficient na hindi purely constant. Merong x squared. Ito rin pala. Dalawa pala sila. So this makes this, since sabi natin, constant coefficient siya exclusively kapag purely constant yung coefficients niya. Then, this is clearly not exclusively constant, but rather merong variable, which makes this a variable coefficient. Okay. Lastly, linear or nonlinear? Is this linear or nonlinear? Again, we have to take a look at our y's. This is our y, and our y. Raised to the power of 1, check. Coefficients, are they functions of x or a constant? Yes, they are. So this is definitely linear. Yeah, so this is a homogeneous variable coefficient linear second order linear differential equation. Mouthful, no? Ang daming sinasabi. Pangalawa, we have y double prime plus 4y prime plus 3y equals e to the x. So, is this homogeneous variable coefficient? And is this linear? The answer is that, una, we take a look again. If we're going to identify if this is homogeneous or not, we take a look at the right-hand side of the equation. This is clearly not equal to 0, so this is non-homogeneous. Very good. How about the coefficients? Are they constant? Yes, they are. All of them. This is constant 1, 4, 3. So this is, So this is constant coefficient. How about linearity? Let's take a look at our y's. Y, and y. Raised to the power of 1? Yes. Check. Yung kanyang coefficients, are they constant or function of x? Yes. As long as hindi siya function of y, linear pa rin siya. Correct? So, in other words, it is a non-homogeneous constant coefficient and then linear. How about the third one? We have y double prime, y plus y prime equals 0. Is this homogeneous or non-homogeneous? Galing! This is homogeneous because of f of x equals 0. Yan. So, madaling tandaan, ano? Basta 0 na nakita mo, no? Huwag lang sa grade. Basta dito sa right-hand side, dyan mo na lang siya panatiliin. This is homogeneous. Okay? Now, let's take a look. How about the coefficients? Are they constant coefficient or variable coefficient? Papansin natin that y double prime and y coefficient, these are all dependent variables that could have a coefficient of either y double prime with respect to y and y with respect to y double prime. So clearly, hindi lang siya constant, no? So this is a variable coefficient. Now, is this linear or nonlinear? We have to take a look at our y's and see that this one is nonlinear. Will make the function nonlinear. Okay? Bakit? Kasi una, we check the power. Okay naman yung power, raised to 1. Kaso, ito, yung coefficient niya is not a function of x. It's a function with respect to the dependent variable. That is why this is homogeneous variable coefficient and nonlinear. Last one. We have y double prime plus sine of x, y prime plus y equals 0. Is this homogeneous? Yes, it is homogeneous because of 0 here. Tama? How about the coefficients? Are they constant or variable? They are almost constant. But because of sine of x here, this made it variable. And finally, are they linear or nonlinear? Nonlinear, tama? Kasi may sine of x dito eh. Eh, hindi naman line yan. Tama? Mali po. Kasi, this is a function of x naman. So, walang kaso dun sa ating y's. We take a look at our y's raised to the power of 1. coefficient niya ay either constant or function of x. So check then. So this is definitely a linear, homogeneous, and variable coefficient second order linear differential equation. All right. Now, we have identified some of the basic terms, no? Pagdating sa higher order DEs, we can now be comfortable identifying them. Now, let us talk about some basic theory of linear equations. Because our primary goal in this chapter, as mentioned already, in this lesson, is to find general solutions of linear higher order DEs. We first need to examine some of the basic theory of linear equations. Now, for example, no, as an illustration, if we are asked to find a solution of y double prime plus y equals 0, no? What do we mean by solution? So, konting refresher lang, no? By theory of solutions. Maalala pa natin doon sa ating previous lessons that we actually, if we are looking for, if we want to find out the solution, then it must be a function that will satisfy the given equation. So recall, let us recall that solutions are functions that will satisfy the equation, no? So anything that will satisfy the equation, we call that the solution. Okay, for example, no, as a refresher for this, let's go back to our basic algebra. For example, we have a function 3x minus 2, 3x minus 2, okay, quantity x minus 4. Yan. Equals 5x. No? So, the question that we always ask in our algebra is that, what will x be? No? Kaya masakit talaga yung algebra kasi laging tinatanong kung ano ba yung x or sino ba yung x. What will x be? Grabe, no? Paano tayo makaka-move on yan kung lagi na lang siya tinatanong? What will be x? That will make the equation. Excuse me. What will be x? That will make the equation true. No? What will make the equation true? In other words, will make the right-hand side of the equation, or rather the left-hand side of the equation, equal to the right-hand side of the equation. Yan. What will make this true? If this is our left-hand side of the equation, ito yun. And this is our right-hand side of the equation. Sorry. Ito, this is our right-hand side. This is our left-hand side of the equation. We usually ask, what will x be to make this true, to make them equal? Okay? Now, pause this for a while and try and solve mentally what x is. Okay nga? 1, 2, 3, 4, 5. X should be equal to? Correct, 2. Okay. So when x is equal to 2, what happens? when x is equal to 2, and we substitute that value of 2 to our equation, magkakaroon tayo ng 3 multiplied by 2 minus 2, quantity 2 minus 4 equals 5, and then multiply to 2. Yan. This will give us 6 minus negative 4, right? Yes. 6 minus negative 4, which is equal to 10. So we know that 6 minus negative 4 is 6 plus 4, and that is 10. So 10 equals 10. Yan. So what can we say and observe from this demonstration that we did? We can notice and conclude, therefore, that indeed x is equal to 2 is a solution. No? So yun yung lagi nating hinahanap, di ba? No? Solution. And what is the reason? Because it's satisfied or made the equation true. Yan. So, yan yung laging concern natin sa algebra, right? To find x so that the equation will be satisfied. Now, this principle is carried out sa differential equations. The only difference is that the solutions here in the context of differential equations ay hindi quantitative value. Rather, they are functions. Okay? Now, going back to our problem, no? If we are asked to find a solution of y double prime, ayun, sabi dito, y double prime plus y equals 0. If we are asked to find a solution, di kailangan natin hanapin yung y double prime saka yung y such that when we add them together, they will be equal to 0. Okay? Now suppose that the solutions, no, just for the sake of illustration, so manghula muna tayo, okay, just to illustrate, some principles of solution. Let us suppose, suppose na lang, yan, suppose that the solution solutions of yun yung nasa taas, y double prime, sulat natin. Suppose that the solutions of y double prime plus y equals to 0, are y sub 1 equals cosine x and y sub 2 equals sine x. Subukan lang natin, this is suppose, What if yung solution ng y double prime plus y equals 0 na differential equation na sa given nating problem ay may solution na cosine x and sine x? How do we verify this? Okay. Then let's try and evaluate. Okay. If the DE is y double prime plus y equals to 0, then at y, so evaluating, let's verify. sulat natin, if, para buo, if the DE is y double prime plus y equals 0, then at y sub 1 equals cosine x, we need to find the values of y double prime tsaka y. Meron na tayong y, ito yun, cosine x. Then we need to find y double prime such that pag nakuha na natin yun, we have to substitute, add them together, and see kung talagang siya ay equal to 0. So, meron na tayong y, that's cosine x, which is yun nga, hula muna natin. So, taking the first derivative, y sub 1 prime, derivative of cosine is negative sine x. The second derivative is what? Negative cosine x. Ayan. So, evaluating if we substitute yung ating evaluating y double prime plus y equals 0, if we substitute yung nakuha na nating values, which is itong y double prime, which is this part, at itong y, which is yung given nga natin na we theorized to be one of the solutions. If we add them together, so we have negative cosine x plus cosine x, eto yun. Is it equal to 0? Well, from the looks of it, negative cosine plus cosine is indeed 0. 0 equals 0. Yan. So what can we say about this? We can therefore conclude that y sub 1 is a solution. So far, anong ginagawa natin? Dinidemonstrate ko na how to make sense of a solution. How do we verify if a function really is a solution? In our context, that's a second-order linear differential equation. Okay? So, ginagawa ko, pinapakita ko muna, nanguhula muna tayo, what if ito yung given function, will it be a solution, no, of the given differential equation? So, yung una nating hulang sagot or solution is cosine x. That's y1 equals cosine x. What if sine x naman siya? No? What if sine x? At y sub 2 equals sine x. Check natin. No? So, yung first derivative ng y sub 2 is, well, cosine x, no? Differentiating. And then yung second derivative is what? Negative sine x. So, plugging in our values, this will give us, so we have evaluating y double prime plus y equals 0. Plugging in our values, ito yung second derivative natin. So sine x, or rather negative sine x, plus yung ating original hula function, sine x. Then equating it to 0. Now, from the looks of it, negative sine x plus sine x, this will be 0 equals 0. What is therefore our conclusion? We can conclude that y sub 2 is a solution as well. Dalawang solution? Yes, kasi second order siya. Diba? Now, second order, dalawang solution. Paano kung pag-combine natin silang dalawa? No? What if we multiply a constant to y1 and y2? Let's say, for example, 2.5 and 1.5. Sige, sulat natin para maliwanag. So far, anong mapapansin natin? Hula tayo ng values, and then we try it out sa equation. If they equate, then it is a solution. But what if we take a step further? What if we multiply a constant to y sub 1 and y sub 2? Let's say, for example, 2.5 and negative 1.5 respectively. And then, let's take it another step further. Take the sum of the results. Ano kayang mangyayari? Well, let's find out. In other words, if we multiply 2.5 sa y1 natin, which is, sabi nga natin, suppose we have y1 is equal to cosine x. If multiply natin yung 2.5 sa cosine x and yung negative 1.5 sa sine x. Therefore, we have y sub 1 equals 2.5. Now, siguro, maaring maitanong nyo na, bakit ba nag-multiply? Again, please hold your horses. I'm simply illustrating cosine x. Yan. Making a point. Y sub 2 equals negative 1.5 sine x. Yan. Now, hindi lang tayo nag-multiply ng constants. Sabi pa natin, what if we take it a little step further? What if we take the sum of these two? In other words, if we represent y to be the sum of y sub 1 and y sub 2, this will give us 2.5 cosine x minus 1.5 sine x. Let's evaluate, no? Tignan natin. Magiging solution pa din kaya siya? By solution, again, we mean, will it satisfy the equation? Will adding the second derivative, gaya nun sa given problem natin, at yung y double prime plus y equals 0, would they be true? Yun yung ating ini-explore. Okay? So, let's evaluate then. Figure out if they will indeed be equal. So, solution. So, evaluating again. Sabi natin, yung sum niya, kukunin natin, y is equal to y sub 1 plus y sub 2. So, from if our DE is, ayun nga, yung given problem, which is y double prime plus y equals 0, then if our y is 2.5 cosine x minus 1.5 sine x, and if we take the derivative of that same function, we have 2.5 negative 2.5 sine x minus 1.5 cosine x, and take another derivative. Bakit tayo nag-take ng second derivative? Kasi yun nga, we need this value so that we could plug it here. So, negative 2.5, derivative ng negative 2.5 sine x is negative 2.5 cosine x. right? Minus, or plus, rather, 1.5. Derivative ng cosine is negative sign. So, negative sign times negative, 1.5. This gives us positive 1.5 sine x. Ayan. Alright. Now, so, nakuha na natin yung mga sangkap. Pagsamasamahin natin sila at ipasok na yan. So, if we have y double prime plus y equals 0, then substituting the values, we have, what is our y double prime? Negative 2.5 cosine x plus 1.5 sine x plus, what is our y? Ito yon, yung y natin. 2.5. So, sana na-appreciate nyo yung ginagawa natin na pagbabalangkas from y prime, and then y double prime para mas madali nating makuha yung mga values tapos i-plug natin siya directly. Kagaya nga yan, sinusulat ko na lang yung value ng y, 2.5 cosine x minus 1.5 sine x para mas madali siyang i-plug and i-solve. Now, so evaluating this, taking the sum, meron tayo ditong negative 2.5 at meron din tayo ditong positive 2.5. So this cancels out. No? Itong 1.5 sine x also cancels out because of negative 1.5 sine x. Thus, no? Surprise! 0 equals 0. What is our conclusion then? That the equation is also satisfied. No? And that means that the sum y equals y1 plus y2 is a solution of the DE. So, pwede pala yun? Alam ko pag second order, dalawa lang yung solutions. So, pwede rin pala na combination sila ng dalawang solution. So, if our solution is cosine x, tapos sine x, satisfied siya. Tapos, pag pinag-add natin sila, tapos nag-multiply tayo ng constant, they also are part of the solution of the DE. We can observe, no? We can make an observation. That the solution seems to have a form of y equals c1, yun yung constant natin, and then yung y1, which is a solution, plus c2 y2, no? Which is a linear combination of y1 and y2. y1 and y2. Now, what do we call this? No? What do we call this linear combination of y1 and y2? There's actually a term for this, okay? And that is what we call linearity or linear combination or superposition. Yan. So, ilan sa mga theory or principles behind the solution of a homogeneous second-order linear differential equations ay itong first theorem natin. Theorem 1, principle of superposition. let y1 and y2 be solutions of the homogeneous linear equation, kagaya nung pinakita natin kanina sa illustration, cosine x and sine x. If y1 and y2 daw are solutions of the homogeneous linear equation as defined by our standard form on an interval I, if c1 and c2 are constants, then the linear combination y equals c1y1 plus c2y2 is a solution on the interval I. Okay? So, superposition. This is what we call the principle of superposition. So, anong sinasabi nito? Kapag ka daw meron tayong solution, we have two solutions, y1 and y2. These solutions is not, yung y1 and y2 can also be combined, no, with a c1 and c2 constants, any c1, c2 constants, no, and it will still be a part of the solution. Yun. So there exists not just two solutions, but many solutions within that interval I. Now, some of you might be familiar or might have heard of the term superposition. Sa mga ECEs, may encounter niyo sa circuit analysis ninyo. Hindi ba sa circuit analysis, there is a technique called superposition. What we actually do there is that if we have two sources, no, that is supplying the circuit, we turn off one source and then solve for a current or voltage, no, with one source active, and then later on turn it off and then turn on naman yung second source, yung another source. And then what do we do with that? We add them together. So linear combination siya. So yung superposition, it applies to linear systems. The principle of superposition applies to linear systems. And we will demonstrate this to this kind of illustration. No? If, let's say, we have y sub 1 equals 1 plus cosine x and y sub 2 equals 1 plus sine x, if they are solutions of linear but non-homogeneous, y double prime plus y equals 1. Let us check, no, if the principle of superposition applies. Ano daw ulit? Kung meron daw tayong two solutions, y1 and y2, yan, given dyan, of the differential equation din na given, which is linear, pero non-homogeneous because of 1. No, because of 1 here. Y double prime plus y equals 1. Linear siya, okay, fine, pero non-homogeneous siya because f of x is not equal to 0. To illustrate, no, na applicable lang yung superposition sa homogeneous functions, let's check, no, and solve this problem. Yeah, okay. All right. So, if we have again our equation, y double prime plus y equals 1. Solution. So at y sub 1 equals 1 plus cosine x, 1 plus cosine x. Check natin, no? Evaluate natin if it is a solution. So yung first derivative natin, y sub 1 prime, is equal to 0 plus negative sine x, derivative ng cosine x. Second derivative is, derivative ng sine x is negative cosine x. Ayan, so kompleto na. So, if we plug this value, no, makakakuha tayo ng evaluating y double prime plus y equals 1. We're going to have negative sine x, negative cosine x, sorry, ito yun. Second derivative, second negative cosine x. Sorry. Negative cosine x And then plus, ano yung y natin? Ito yun, given 1 plus cosine x. 1 plus cosine x equals 1. Well, obviously here, cosine cancels out. And we're left with 1 equals 1. Okay, so what have we seen here? We will notice na, okay naman pala, yung 1 plus cosine x, solution naman siya nung given DE na y double prime plus y equals 1. Okay, tignan naman natin, no? Dun sa second proposed solution natin, or stated solution, we have 1 plus sine x at y sub 2 equals 1 plus sine x. Okay, so if we evaluate this, evaluating y double prime plus y equals 1, we'll be needing yung first and second, or rather yung second derivative for this. So differentiating the function, we have y sub 2 prime equals 0 plus cosine x. And then taking the second derivative will give us 0 minus sine x. And so evaluating y double prime plus y equals 1, this will give us, so what's our y double prime? Ito yun, negative sine x plus, what is our y? Ito yun, 1 plus sine x, 1 plus sine x. Will it be equal to 1? Well, you'll see here that sine x, negative sine x, and sine x cancels out. And so we have 1 equals 1 pa din. Okay? What is our conclusion here? Well, indeed they are solutions of y double prime plus y equals 0. Okay tayo dun. Independently, they are solutions. But what if we combine them? We take the sum, no? At y equals y sub 1 plus y sub 2. Yan. What if we combine them together? Will it still give us the same solution? Move ko lang to saglit. Yan. So what will happen? So y natin is, y sub 1 is 1 plus cosine x, 1 plus cosine x. And then y2 natin is 1 plus sine x. Yan. Now, taking the first derivative, this will give us 0 plus derivative ng cosine x, negative sine x, plus derivative ng 0, ng 1, ang constant is 0, plus derivative ng sine x, that's cosine x. Correct? So how about the second derivative? So derivative ng sine x or negative sine x is negative cosine x. And then derivative ng cosine x is negative sine x. Okay. So evaluating yung given DE natin, which is y double prime plus y equals 1, will give us, plugging in our values, meron tayong, what is our y double prime? Ito yun. That's negative cosine x minus sine x. Oops. negative cosine x minus sine x. Okay, and then plus. What is our y? We have 1 plus cosine x. Combine na natin. 1 plus cosine x plus 1 plus sine x. So this gives us 2 plus cosine x plus sine x equals 1. What can we notice here? Negative cosine x and cosine x cancels out, as well as negative sine x and sine x. And so we're left with, interesting, 2 not equal to 1. So what is our conclusion here? Conclusion is that the superposition principle does not apply. Yeah. When we mean superposition, it's the linear combination of the possible solutions. In this case, hindi siya naging equal when we evaluated it. Therefore, sa non-homogeneous, again, pag non-homogeneous, ano lang sabi natin? Pagka yung function natin, yung f of x dun sa given DE natin, which is y prime plus y equals 1, pag yung f of x niya, yung nasa right-hand side, not equal to 0, then it is non-homogeneous. No? In this case, 1 yung nasa dulo niya. It is therefore non-homogeneous. And we have demonstrated that the superposition principle does not apply to non-homogeneous. Okay? Let's take another illustration. Now, if we have y sub 1 equals x squared plus and y sub 2 equals 1, if they are solutions of the homogeneous but nonlinear DE, which is y double prime y minus x y prime equals 0. Let us check if the principle of superposition applies sa non-linear. Okay? So again, evaluating. Yeah. So we have y double prime, hindi natin, y double prime, y minus xy prime equals 0. Solution, at y sub 1 equals x squared. So, evaluate muna natin yung ating DE. Y sub 1 prime is 2x and y sub 1 double prime is 2. So, evaluating the DE, magkakaroon tayo ng y double prime times y. Ano yung y double prime natin? Ito yun. Evaluating natin itong DE na to. Y double prime, which is 2, multiplied by y, which is x squared, minus x, and then ano yung y prime natin? 2x. And is it equal to 0? Well, from the looks of it, we have 2x squared minus 2x squared, then we have 0. 0 equals 0. Therefore, our conclusion is that, yes, x squared is a solution of the given DE. Now, let's try naman and see dun sa pangalawa. Y sub 2 equals 1. So, constant, no? So, very obvious. First derivative ng constant ay 0. Second derivative ng constant ay 0 pa din. Substituting, evaluating the DE, gives us, well, 0 for everything. 0 minus x and then multiplied by 0 equals 0. Since 0 is equal to 0, indeed, it is still a solution of the given differential equation y double prime y minus xy prime equals 0. But how about the linear combination of the two? Okay. That is at y equals y sub 1 plus y sub 2, which is x squared plus 1. Sige, babaan lang natin dito. So at y equals y sub 1 plus y sub 2, we have y is equal to x squared plus 1. Taking the first derivative gives us 2x plus 0. Derivative ng constant, 0. Taking the second derivative, we have 2. Okay, so evaluating the dE, substituting the value of our derivatives, we have y double prime y. So yung y double prime natin, 2 multiplied by x squared plus 1. And then minus x, and then yung value ng y prime natin? Ito yun, 2x equals 0. Will this satisfy the equation? Well, meron tayo ditong 2x squared plus 2 minus 2x squared. And it can be noticed that 2x squared cancels out. Pero, may natirang 2. Therefore, 2 is not equal to 0. Our conclusion is, therefore, what? Superposition principle does not apply. Yan. Okay? So, in conclusion, or in summary, hindi pa pala conclusion. In summary, to summarize, hindi applicable yung principle of superposition, that is, yung linear combination of two solutions, sa nonlinear and non-homogeneous. I hope our illustration made that clear. Okay? Okay. So, moving forward, another important theorem, that we need to understand is what we call the existence and uniqueness of solution. Okay, so since we're heavily interested in looking for the solution of a differential equation, it is then therefore important for us to understand if there exists and if there is a unique solution to the differential equation. Kasi useless yung pagsosolve ng DE kung madami palang solution. No? The challenge is to know every solution. Kaya, una, kailangan nating malaman kung meron nga talaga nag-exist na solution and if there is a unique solution for that. You may recall from previous lesson that for a first-order ordinary differential equation, an initial value problem, an IVP, consists of what we call an initial value condition. Naalala pa ba? Pag nagsusolve tayo ng DE and we want to know a particular solution, merong side conditions sa kanya. Let's say y of 0 equals 3, correct? The initial condition is used to determine the arbitrary constant C that we solve in the general solution ng ating DE. So this results in a unique solution, and as we need it in most application. Now, the solution is called particular solutions. Pag nahanap na natin yung value for the arbitrary constant of the differential equation. So these ideas extend to second order differential equations. to solve second order linear differential equations. For a second order homogeneous linear differential equation, initial value problems consists of two initial conditions. So para ma-solve mo ang isang second order, dapat meron ka ding two initial conditions. Again, kung gusto mong makasolve ng particular solution, for an nth order DE, kailangan n number of conditions din. In our case, second order yan. So, two conditions ang kailangan para ma-solve siya. Sa madaling sabi, may unique solution ka na makukuha kapag ka may certain conditions applied sa iyong initial value problem. So formally, suppose that there are functions P, Q, and F, yun nga sa standard form natin, that are continuous in an open interval I, containing the point A. Then given any two numbers, let's say B sub 0 or B naught and B sub 1, the equation, which is the standard form as seen on the screen, y double prime plus p of x, y prime plus q of x, y equals f of x, has a unique, what do we mean by unique? One and only one solution on the entire interval I that satisfies the initial condition. So yun yung ating madaling sabi. Kung meron tayong conditions, meron tayong makukuhang unique solution. So these initial conditions will satisfy the given differential equation. Let's take an example to better appreciate this. So continuing from our previous example, recall na yung given nating y1 and y2 are cosine x and y sub 2 is sine x, right? So let us apply this with our given initial value conditions to solve or find the solution of y double prime plus y equals 0. Okay, so from our given solution, from the theory of superposition, sabi natin a solution exists as a linear combination. So we have y equals c1 y1 plus c2 y2, where y sub 1 is yun nga kanina, we have cosine x plus c sub 2 as sine x. Now taking the derivative of that solution will give us negative c sub 1 sine x plus c2 cosine x, and taking another derivative, or the second derivative, we have negative c1 cosine x, derivative ng sine x ay cosine x, minus c2 sine x. Alright. Ngayon na nakuha na natin yung mga kailangan natin to evaluate our DE. So, substituting or evaluating at y of 0 equals 3, no? Yung first given condition natin. So at y of 0 is equal to 3, we have since yung ating initial value condition is involving y only, not y prime, not y double prime, then we need to use this equation to apply that. And so we have y. We have y equals c1 cosine x plus c2 sine x. And substituting, we have y is equal to 3 daw when x is equal to 0. c1 cosine 0 plus c2 sine 0. This gives us cosine 0 is 1. You know, this is 1 and sine 0 is 0. Thus, c1 is equal to 3. Okay? And nakuha na tayong arbitrary constant. Now, at the second condition is y prime of 0 equals negative 0.5. So, yung y prime natin is this one. Okay? So, dito lang natin siya pwedeng i-apply kasi nga, yung condition is y prime is equal to negative 0.5 when x is equal to 0. Then, y prime equals negative c1 sine x plus c2 cosine x. Okay? This gives us negative 0.5 equals si c1 nakuha na natin, which is 3. That's negative 3. Then sine, then 0 plus c2 cosine 0. This one is sine 0 is 0, cosine 0 is 1. Therefore, c1 is, or rather c2 is equal to negative 0.5. Ayan. Alright. Now that we have yung ating value for c1 and c2, thus, the general solution of the differential equation y double prime plus y is equal to 0, given that y sub 1 is equal to cosine x and y sub 2 is sine x, the general solution is y equals c1 cosine x plus c2 sine x. Whereas the particular solution is 3 cosine x plus negative 0.5 sine x. Yan. Particular solution because we were able to solve for C1 and C2. Okay? So, ganun lang. Alright. Let's move on to another problem. Okay. So, example number 2. Verify, given the differential equation y double prime minus 2y prime plus y equals 0, we're asked to verify that y sub 1 equals e to the x and y sub 2 equals x e to the x. We are to verify if they are, or that y sub 1 e to the x and y sub 2 equals x e to the x are solutions. That's number 1. Number 2, we're asked to verify that y equals c sub 1 y sub 1 plus c sub 2 y sub 2 is a solution if c sub 1 and c sub 2 are arbitrary constants. And finally, we're asked to solve for the initial value problem if y of 0 is equal to 3 and y prime of 0 is equal to 1. Okay, so let's go ahead and solve this one. So for A, we're asked to verify that y sub 1, e to the x, and y sub 2, x e to the x are solutions. Sige. So, verify natin yun. Una muna at y sub 1 equals e to the x. So, y sub 1 is e to the x, whereas y sub 1 prime is e to the x then. And y sub 1 double prime is also e to the x. So, evaluating y double prime minus 2y prime plus y equals 0, which is our given differential equation, kakaroon tayo ng, we have y double prime, ito yun. Y double prime natin, ito yung equivalent niya, and ito yung y prime. And then obviously y is also this one. So substituting it all together, kakaroon tayo ng e to the x minus 2 e to the x plus e to the x. The question is, are they equal to 0? Well, let's find out. E to the x plus e to the x is 2 e to the x minus 2 e to the x. Well, indeed, that would be equal to 0. So 0 equals 0. That's how we verify a solution. What is our conclusion? Therefore, y sub 1 is a solution. Okay. How about at y sub 2 equals x e to the x? Okay. So first derivative is product rule. X e to the x will give us derivative ng first term x will give us e to the x plus derivative ng second term e to the x is also e to the x, therefore x e to the x. And the second derivative will be derivative ng e to the x is e to the x plus yan, e to the x plus x e to the x. All right. So evaluating y double prime minus 2y prime plus y equals 0 gives, we have y double prime, medyo mababa, e to the x plus e to the x x e to the x minus 2 e to the x plus x e to the x plus, what is our y? X e to the x. And we'll see if this will all be equal to 0. Well, expanding this, going to have 2 e to the x plus x e to the x minus 2 e to the x minus 2x e to the x plus x e to the x. Simplifying, we'll notice na 2 e to the x minus 2 e to the x is 0. And then x e to the x and x e to the x when added will become 2x e to the x. But minus 2x e to the x will also give us 0. Therefore, 0 equals 0. What is our conclusion? The conclusion is y sub 1, or rather 2, is a solution. Indeed, both y sub 1 and y sub 2 are solutions. Let's move on to the next item, B. We're asked to verify excuse me, at y equals c sub 1, y sub 1 plus c sub 2, y sub 2. Okay. If it is a solution, part of the solution. So we have y. We have y equals c sub 1. Yung y sub 1 natin is e to the x, yung nasa given sa a, e to the x, plus c sub 2, x e to the x. Okay? So, yung first derivative niya will give us c1 e to the x, same, plus derivative ulit ng x e to the x, product rule, we'll have c2 e to the x plus x e to the x. Finally, yung second derivative will be derivative nito will be the same, c1 e to the x plus derivative ng c2 would be e to the x plus e to the x, x e to the x. Yeah. Okay. So evaluating y double prime minus 2y prime plus y equals 0 gives, substituting the values, y double prime, medyo mahaba, no? We have c1 e to the x plus, we combine these two, kakaroon ako ng 2c2 e to the x plus c2 x e to the x. Okay? Minus 2 ng y prime, which is this one. I have, okay, diretso ko na, 2c1 e to the x minus, or ano ba? Hindi, sige. Para hindi nakakalito. Maintained yung y prime c1 e to the x plus c2 e to the x plus c2 x e to the x. Ayan. Then finally, plus y, which is, of course, c1 e to the x plus c2 x e to the x equals 0. Okay? So, expanding will give us negative 2 c1 e to the x minus 2 c2 e to the x minus 2 c2 x e to the x plus c1 e to the x plus c2 x e to the x. So c1 e to the x, copying it down. Yan. Equals to 0. Medyo mahaba-haba. But let's try. So lahat ng c1 e to the x ay ito. c1 e to the x, c1 e to the x, c1 e to the x. So c1 e to the x plus c1 e to the x will be 2c1 e to the x. Kasi meron tayong negative 2c1 e to the x, so they cancel out. Cancel, cancel, cancel. Next, lahat ng c2 e to the x. Ito yung c2 e to the x, c2 e to the x, and yan lang. So 2c2 e to the x minus 2c2 e to the x, they cancel out again. Next is yung c2x e to the x. Yung c2x e to the x ay ito. to din. Yan. And ito. Yan, tama. So, c2x e to the x plus c2x e to the x will become 2c2x e to the x. Kasi meron kang minus 2c2x e to the x dito. Kaya, charan, surprise. Yes, 0 equals 0. Okay? So, verify. Conclusion, therefore, y equals c1, y1 plus c2, y2 is a solution. Okay. All right. Next, yung third item natin, we're asked to solve the initial value problem. No? C. The initial value problem at y of 0 equals 3 and y prime of 0 equals 1. So, unahin natin yung y of 0 equals 3. Okay? Nakuha na natin yung general solution kanina, which is from item B. So, from item B, we have y equals c1 e to the x plus c2 x e to the x. Okay, so substituting, we have 3 equals c1 e to the 0 plus c2 0 e to the 0. So this cancels out as 0. Therefore, c1 is equal to 3. Yan. Okay, now at y prime of 0 equals 1, this gives us y, first derivative ng ating y. If this is our y, c1 e to the x and plus c2x e to the x, di-differentiate natin, y prime will become c1 e to the x plus c2 e to the x plus x e to the x. Ayan. Okay, so substituting, magkakaroon tayo ng 1 equals c1 e to the 0 plus c2 e to the 0 plus 0 multiplied to e raised to 0. Yeah. This clearly cancels out as 0. Okay. And then c1 natin is equal to 3, right? So substituting it here, magkakaroon ako ng 1 equals 3 plus c2. Thus, c2 equals negative 2. Okay, and c2 is equal to negative 2. Now, what can we say about this? Thus, since we're looking for the solution, solve daw the IVP, the initial value problem. If the general solution is c1 e to the x plus c2 x e to the x, then the particular solution, given our conditions, is equivalent to 3 e to the x plus negative 2 x e to the x. Ayan. So there we have it. Our solution. No? So ang hinahanap naman dito is itong particular solution, pero pinakita ko na rin yung general solution para alam natin kung saan siya nanggaling. Right? Okay. So let's move further. Now, balik tayo dun sa una nating example, no? Continue natin ng kaunti. And let's ask ourselves, what if, no? What if our choice for y1 and y2 was general enough to satisfy both the initial conditions, no? Let us say we have here our given y sub 1 to be cosine x and y sub 2 to be equal to k cosine x. No? Again, another thought experiment or illustration. No? So, what can we notice here? Paano kung cosine x yung y1 natin and k cosine x yung y2 natin? We will notice here that y1 and y2 are proportional solutions. No? So, y2 or y1 and y2 here are proportional solutions. Okay, they are proportional solutions. Proportional in the sense that, well, related sila to one another because cosine x tsaka k cosine x, yung kanilang expression or relationship can be expressed as a factor of each other. Yun yung ibig sabihin ng proportional. So notice here, no, that if we divide y1 and y2, take the ratio of y1 and y2, we will have 1 over k. Okay, so ulitin natin. We have cosine x over k cosine x. So obviously, k cancels out. And we're left with 1 over k, where k is a constant, of course. And we'll notice na since 1 and k are both constants. No? So in other words, 1 over k, their proportion, can be expressed as a, let's call it a constant. No? Now if we write the solution in the form of y sub 1 or y equals c sub 1 y sub 1 plus c sub 2 y sub 2, then magkakaroon tayo ng y equals c sub 1 cosine x plus c sub 2 k cosine x. Sinubstitute lang natin yung value ng y1 at y2. And what will we notice? Can actually factor out cosine x here and have c1 plus c2 k and then cosine x. Now, if we since pares naman silang lahat na constant, c sub 1 plus c sub 2 k be equal to c, no, as one representation for the arbitrary constants, magkakaroon tayo ngayon ng y, the solution, to be c and then cosine x. No? Cosine x. Dito galing, no? So, okay. Now, what can we observe here? Observe, no, that two initial conditions can no longer, sorry, sinusulat ko pa, can no longer be satisfied with only one arbitrary constant. In this case, yung ating C, no? Anong ibig sabihin nito? What's the meaning of this? Kasi if we have a second order differential equation, edi we need two side conditions para makuha yung particular solution. Tama? Pero in this case, if they are proportional with each other, what can we notice? Yung constants, the two initial condition can no longer be satisfied with only one arbitrary constant kasi nga kailangan natin ng dalawa. Right? Since they are all constants and can be represented by a single C, hindi na siya kayang isatisfy. Now, what is the meaning of this? The meaning of this is that in defining, lipat ka na sa kabila, no? Anong ligayang makakamit natin, no? Anong makukuha natin, mahihinita mula dito sa ating illustration? What is the meaning of this? In defining, therefore, the concept of a general solution, in defining the concept of a general solution, we must exclude proportionality. Yan. That is why it is important to understand the concept of general solution in relation to the initial value problem. Ano daw? Ano ibig sabihin nito, no? Balikan natin. Pagka proportional yung dalawang solutions, no? The two initial conditions can no longer be satisfied with only one arbitrary constant C. Kasi nga second order siya or more. If the constants can be expressed into a single constant, it can no longer satisfy, no? The meaning of this is this, that in defining the concept of a general solution, we must exclude proportionality. So, dapat hindi proportional yung solutions. Kung gusto natin makahanap ng fundamental set of solution, we must exclude proportionality. Yan. So, dapat hindi siya proportional, hindi siya dependent to another solution. In other words, siya dapat ay independent. And these forms are basis of a solution. Okay? Again, ano ulit? We must exclude proportionality, and therefore, for us to be able to find the fundamental set of solutions, they must be independently related. Okay? And these forms are basis of a solution, no? And a basis of a solution of a standard form of a differential equation with a standard form of y double prime plus p of xy prime plus p of xy is equal to 0 on an open interval I is a pair of linearly independent solutions of that differential equation on the interval I. Okay? So, dapat yung solutions natin, they must be linearly independent. Please take note of that. Linearly independent. Now, anong ibig sabihin ba noong linear independence and dependence? What does it mean? What do we mean by linear independence and dependence of functions? Allow me to analogize it this way, no? When a couple goes out on a date, diba? And the gentleman asks the lady, what does she want? What do you want, no? For dinner, tapos nag-respond si girl na, ikaw bahala, no? Ang ibig sabihin nun, dependent yung sagot niya doon sa choice ni guy, no? Pag sinabi niya, ikaw bahala, that is a dependent answer kasi her choice would be based on his decision, no? His decision then affects her decision. Pag sinabi ni girl na, ikaw na bahala kung anong gusto. Dependent yung kagustuhan niya sa kagustuhan din ni guy. Now, if the lady is a so-called strong independent woman, okay, she might respond to the viand of her liking for the dinner. The gentleman's decision on what food to eat does not affect her decision, no? So, sana all make a date. Lol. Na in a similar fashion, no? Ganun din. When we say a set of functions y sub 1, y sub 2, until y sub n, which are solution, is linearly dependent in an interval I if there exists constant c1, c2, cn where they are not all constant, such that c1, y sub 1 plus c2, y sub 2 until cn, y sub n is equal to 0, no? This forms the relationship, no, of the set of functions y sub 1, y sub 2. They are linearly dependent kapag when you add them all up, when you add all of the combinations of solutions all up, they will end up to be equal to 0. Okay? In other words, let's say for example, for a second order DE, kung meron kang C1 y1 plus c2 y2 equal to 0, they are linearly dependent if you can express the solution y sub 1 as a constant multiple of another. So if you have y sub 1, if you express it in terms of y sub 1, edi magkakaroon ako ng, transpose ko itong c2 y sub 2 sa kabila, magkakaroon ako ng negative c2 all over c1 y sub 2. So the relationship now between y sub 1 and y sub 2 is that they are constant multiple of one another. And if that is the case, they are called linearly dependent. Okay? Linearly dependent. Again, to state it this way, two functions are linearly dependent if one is a constant multiple of the other. At yun nga yung illustration natin, y sub 1 can be expressed as negative c2 all over c1 y sub 1. Y sub 2 pala. So we see here that y sub 1 is a constant multiple. Ito yung constant multiple of y sub 2. They are linearly dependent. Now, if two functions are linearly independent, if neither is a constant multiple of the other. Kapag hindi na sila constant multiple of the other, ibig sabihin, they are not anymore dependent. Okay? So, ganun. Mamaya explain natin kung bakit, kung paano pa mahahanap yung linearly independent. Kasi ang important sa ating maintindihan ay, kagaya ng na-explain ko kanina sa basis of solution, what we are actually looking for if we want to find the fundamental set of solution is those that are linearly independent. Okay? So, importanteng maintindihan natin kung ano yung pagkakaiba ng linearly dependent and linearly independent. But then again, what we are actually more interested in is to find out if a set of solutions, say y sub 1, y sub 2 until y sub n, are linearly independent. Because if they are, then they are the fundamental set of solutions. Okay? But first, if we are asked to find, just for a point of demonstration, if functions or if two functions or a set of functions are linearly dependent, paano natin yun gagawin? And that is the point of this example. What are the values of c sub 1, c sub 2 that will make the functions y sub 1 e to the 2x and y sub 2 e to the 2x raised to e to the 2 quantity x minus 1 linearly dependent from negative infinity to positive infinity. Okay, so let's solve. All right. So, ano yung mga given natin? Let's quantify the problem. Meron tayong y sub 1, and that is e to the 2x. Meron din tayong y sub 2, and that is e raised to 2 quantity x minus 1. Okay? Now, anong pinapahanap sa atin? What is C1 and C2 for it to be linearly dependent? No? Linearly dependent. Okay. Now, analysis. How do we define again? If a set of solutions or if a set of functions are linearly dependent, they are linearly dependent if their sum, c sub 1, y sub 1, plus c sub 2, y sub 2, plus c sub n, y sub n is equal to 0. So, pag equal to 0 sila, they are linearly dependent. Okay, so solution. Okay. Sabi natin, c sub 1, y sub 1, plus c sub 2, y sub 2 equals to 0. So, meron tayong dalawa dito na y sub 1. So, substituting, we want to know what would make the whole function or the whole equation 0 by looking for c sub 1 and c sub 2. So, substitute natin. C sub 1, y sub 1 is e to the x plus c sub 2, e raised to 2x minus 1 equals 0. Yan. Okay? So, expand natin tong si c sub 2. C sub 2 can also be expressed as c sub 2 e raised to 2x times e raised to negative 2. So, dinistribute ko lang yung 2 papunta rito sa x tsaka papunta rito sa negative 1. Okay? And by properties of logarithms, this could be expressed to as 2x, e to the 2x times e to the negative 2 equals 0. Okay? Now, if you want to figure out what C1 and C2 is, we can use ratio and proportion, no? Because they are proportional, no? And paano yun? E, dilipat ko lang, no? Si C1, or si C2 sa kabila, magkakaroon ako ng C1 e to the 2x equals negative C2 e to the 2x multiplied by e raised to negative 2. By ratio and proportion, yan ko muna. So, divide ko muna si C1 and C2. C1 over C2 equals, yan. Papansin natin, C2 or e raised to 2x cancels out, this one. And I am left now with negative e raised to negative 2. So, by ratio and proportion, this is also equivalent to negative 1. And then baba ko yung e raised to 2, right? And e raised to 2 is a constant. Thus, by ratio and proportion, by ratio and proportion, C1 equals -1 and C2 equals E raised to 2. Okay? Yan. So these values for C1 and C2 will make the set of functions linearly dependent. Okay? Linearly dependent. All right. Let's take a look at another example. What are the values of C1, C2, and C3 that will make the functions y sub 1 equals to 3, y sub 2 equals to cosine squared x, and y sub 3 sine squared x linearly dependent on negative infinity to positive infinity? So yun yung definition natin for the interval I. Okay? So, let's try and solve this. Okay, so let's quantify the problem. Ano yung mga binigay sa atin? Well, we have y sub 1, 3, bigyan tayo ng y sub 2 equals cosine squared x. Yes. And finally, y sub 3 is sine squared x. Tama? Okay. Now, what is required of us to find? Napahanap sa atin yung value ng C1, C2, and C3. Again, that will make the functions or set of functions linearly dependent. Okay? So, sabi natin, a set of functions are linearly dependent if the sum of them are equal to 0. Okay? So, substituting solution, we have C sub 1, y sub 1, which is 3, plus C sub 2, cosine squared x, plus C sub 3, sine squared x equals, of course, 0. Ayan. So, meron tayong trigonometric identity here, cosine squared x and sine squared x. Recall from your trigo na identity yan. Diba? Sine squared theta plus cosine squared theta is actually equal to 1. Right? So, if we if we let C2 and C3 be equal, no? If we let C2 and C3 be equal. And kung i-analyze natin yung ating given equation, meron tayo ditong C1 multiplied by 3 na constant dito. Tama? So, if I let C1 and C3 to be equal to 3, no? Kung itong C2 and C3 magiging 3, and then itong C1 ginawa kong -1, magkakaroon ako ng -3 plus 3, and that will make it 0. Tama? Well, pwede rin naman gawin na ito yung magiging 1. Ito yung magiging 1 at ito yung magiging -3. Parehas lang din siya. It doesn't really matter in particular kung ano yung dapat maging value ng C1, C2, and C3 as long as they are made linearly dependent. So, if I let C2, C3 be equal to 3 and C1 be equal to -1. If I substitute these values, magkakaroon ako ng C1 multiplied by -1 plus C2 is equal to 3 cosine squared x plus 3 sine squared x. Equals 0. Again, if we factor out this 3, I'm sorry, ito pala ay dapat -1 and then this should be 3. So this will become 3, -3, plus if I factor out 3 here, itong 3 na to at itong 3 na to I factor out, magkakaroon ako ng cosine squared x plus sine squared x. And by trigonometric identity, that is equivalent to 1. No? Then therefore, -3 plus 3 is equal to 0. Right? Therefore, our answer is C2 equals C3, or therefore C1 equals -1, C2 equals 3, and C3 equals 3. Yeah. These values will make the set of solutions linearly dependent. Okay? Yeah. Well, pwede magkakabaliktad yan, walang kaso. Okay. Another example. What are the values of C1, C2, C3, and C4 that will make the functions y sub 1 equals sine squared x, y sub 2 cosine squared x, y sub 3 secant squared x, and y sub 4 tangent squared x linearly dependent on an interval from -infinity to +infinity? Okay, let's try and solve this. Again, quantifying the problem. Ano yung mga binigay sa atin? 4 na to, no? So, meron akong y sub 1, sine squared x. Meron akong y sub 2, cosine squared x. Meron akong y sub 3, secant squared x. Y sub 4, tangent squared x. Right? We are asked to figure out what C1, C2, C3, and C4 values be. No? What will their values be? So analyzing the problem, no? From our definition of linear dependence, the linear combination of the 4 sets of solutions will be C1 y1 plus C2 y2 plus C3 y3 plus C4 y4 is equal to 0. Okay? And thus, no, substituting solution, C1, or rather y1. So meron tayong sine squared x plus C2 cosine squared x plus C3 secant squared x plus C4 tangent squared x. Yan, equals 0. Ayan. Now, you may recall, again, from trigo, yung ating identities. Ito, we have already mentioned this. Sine squared theta plus cosine squared theta equals 1. Pero there are also other expressions of this. If we actually divide this whole equation, no, by cosine squared theta, magkakaroon tayo ng equivalent na tangent squared theta kasi sine over cosine, so katawa, plus 1, cosine over cosine is 1, equals 1 over cosine is secant squared theta, right? So from these two identities here, we can actually manipulate itong secant squared x and tangent x, as well as sine squared x and cosine squared x. And we're going to get, no, so magkakaroon tayo ng, if I let lang ba? O, sige, dito lang. If I let C1 equals C2 equals 1, no? And C3 equals C4 be equal to negative 1. Actually, pwede ring 2, pwedeng negative 2, pwedeng 3, negative 3. No? As long as it is made dependent. Yan. So, if I let these values, 1 and negative 1, be substituted here, magkakaroon tayo ng equivalent na expression as yan. 1 sine squared x plus 1 cosine squared x plus negative 1 secant squared x plus negative 1 tangent squared x equals 0. Okay. We'll notice here na this one, this part here, okay, and this part here will simply be equal to 1 and negative 1. And so 1 minus 1 equals 0. Therefore, 0 equals 0. No? And therefore, the values of C1 will be 1, C2 will be 1, C3 will be negative 1, and C4 will be negative 1. Yeah. That is our solution for this problem. Okay? Okay. Let's now move on to another concept. Now, getting functions to be linearly dependent is quite a guesswork, no? Mapapansin nyo, nag-let tayo to be able to find out or figure out what constants will make this set of functions to be linearly dependent. It's quite a guesswork, no, it seems. But the question we might ask, no, is there a way to determine if a set of functions are linearly dependent or independent? Meron bang paraan para malaman natin kaagad kung itong set na ito, without the guesswork, no, are linearly dependent or independent? Well, there's good news, because there is, no, and it is called the Wronskian of solutions. The Wronskian of solutions. And that is our third theorem. Ang sabi dito, suppose that y sub 1 and y sub 2 are two solutions of the homogeneous second-order linear equation, in standard form, y double prime plus b of x, y prime plus b of x, y equals f of x, on an open interval I, on which p and q are continuous. If the Wronskian of the set of solutions or functions y sub 1, y sub 2 is equal to 0 for all x in the interval I, then y sub 1 and y sub 2 are linearly dependent on I. Okay? Ano daw ulit? Kagaya ng ating definition ng linearly dependent, pagka daw yung Wronskian noong set of functions na yun ay equal to 0, they are dependent. Pagka hindi equal to 0, they are linearly independent. Linearly independent. O madaling tandaan. Hindi. Zero. Independent. Okay. Okay. Last ko na yan. Sorry. Okay. Now, what do we mean by Wronskian? What is the Wronskian? Actually, the Wronskian is the determinant. Yan. So, babalikan natin yung ating algebra matrices. If we have y sub 1, y sub 2, until y sub n, we have at least n minus 1 derivatives. Now, to be able to find the Wronskian of the function, we have to find out the determinant of this set of functions with their respective derivatives. In other words, kung meron kang 2 set of functions, edi meron kang 2 by 2 na matrix. Okay? And that is y sub 1, y sub 2, and then yung derivative ng y sub 1 and y sub 2. So kung mapapansin nyo, narito yung y sub 1 at narito yung y sub 2. No? Ito yung y sub 1, ito yung y sub 2. Kunwari, kung 2 by 2 yan, edi yung nasa ibabaw ay yung original na set of functions mo. At yung nasa baba niya ay yung derivatives niya. Okay? So kung 2 lang yung functions mo, edi 2 by 2 lang siya. Pag tatlo yung functions mo, edi 3 by 3. Y sub 1, y sub 2, y sub 3. Yung first derivatives niya, and then yung second derivatives niya. So paano ko malalaman kung ano yung dapat na ilagay ko dito, and how many times will I differentiate? That should be n minus 1. Okay? N minus 1. In other words, kung meron akong 5 set of functions, wag naman sana, magkakaroon ako ng 4 times na differentiation sa kanya. Magkakaroon ako ng 5 by 5 matrix. No? 5 by 5 matrix. So, that is how we determine if the set of solutions are linearly dependent or linearly independent. Okay? Alright. So, the value of the Wronskian can help us determine if the functions are dependent or independent. Okay? Let's take another example for us to better appreciate itong ating new learning of the Wronskian. So, find if the following set of functions are linearly dependent or independent. Okay? Find if the following are linearly dependent or independent. Alright. So, for A, gagamitin natin yung Wronskian para malaman natin if they are linearly dependent or independent. Ano nga uli? Pagka yung Wronskian equal to 0, they are linearly dependent. Pagka hindi equal to 0, they are independent. Okay? So, let's solve for the Wronskian of item A. We have the Wronskian of x squared plus 2x and x squared minus 2x. Okay? So, let's form our matrix since dalawa siya. So, it's a 2 by 2 matrix wherein yung nasa top na entries, x squared plus 2x and x squared minus 2x, yun yung unang entry. And then sa baba niya ay yung kanyang derivatives. So, 2x plus 2 and then 2x minus 2. How do we get the determinant for this? We multiply, no? Cross multiply and then subtract sa 2 by 2. No? So magkakaroon tayo ng x squared plus 2x multiplied by 2x minus 2 minus x squared minus 2x times quantity 2x plus 2. Yan. So this will give us distributing, magkakaroon tayo ng, okay lang, shortcut ko na, 2x cubed plus 2x squared minus 4x. Okay? Minus 2x cubed minus 2x squared minus 4x. Okay? And taking the sum, of this will give us actually 0. Therefore, the Wronskian of x squared plus 2x and x squared minus 2x is actually equal to wait lang. Hindi pala equal to 0 ito kasi may matitirang no. Sorry. May matitirang 4x. May matitirang 4x squared. Yan. May matitirang 4x squared. Kasi makakancel to. 2x cubed minus 2x cubed. And then 2x squared plus 2x squared. So 4x squared. So the Wronskian of x squared plus 2x and x squared minus 2x is not equal to 0. No? Therefore, what is our conclusion? It is linearly independent, hindi 0. No? Therefore, the conclusion is the Wronskian is linearly independent. Yan. The Wronskian is not equal to 0, therefore it is linearly independent. Yun na naman ang pinapa-identify sa atin if the functions are linearly dependent or independent. Okay? Next. Sorry. So, let's take another example. Item B. We're asked to find the Wronskian of sine 2x and cosine 2x. So the Wronskian of this will be again a 2x2 matrix. Yung nasa ibabaw ay yung given cosine 2x and sine 2x and cosine 2x, and then sa baba niya ay yung derivatives niya. So meron tayong derivative ng sine is cosine 2 cosine 2x, and then negative 2 sine 2x. So again, getting the determinant, the Wronskian is actually the determinant of this set of functions. This will give us negative 2 sine squared 2x minus 2 cosine squared 2x. Okay? Again, recall from our trigonometric identity, sine squared theta plus cosine squared theta is equal to 1. Therefore, if we factor out negative 2, no, kakaroon tayo ng sine squared 2x plus cosine squared 2x. And this is actually equivalent to 1. Yeah, sorry. So thus, the Wronskian is again not equal to 0. The Wronskian of negative 2. The Wronskian of sine 2x and cosine 2x is not equal to 0. Therefore, our conclusion is that it is linearly independent. Hindi 0 eh. Okay? Yan. Okay. Next. So sa C, we have 2 raised to x plus 3 and 2 raised to x. Okay? what is the Wronskian or the determinant of the functions or the set. So, since 2 yan, we need a 2 by 2 matrix. Copy muna natin yung una, 2 raised to x plus 3. And then, itong isa ay 2 raised to x. Now, yung baba ay yung derivatives ng 2 raised to x plus 3 and 2 raised to x. Okay? Ano yung derivative nila? Recall, yung identity natin, no? Or yung derivative ng exponentials. Derivative of a raised to u is equal to ln of that a multiplied by a raised to u. Copy natin ito. And then, yung derivative ng ating exponent. So, in this case, for the derivative of 2 raised to x plus 3 will then be equal to ln 2 multiplied by 2x plus 3. Copy natin siya. And then yung derivative, which is derivative ng x plus 3 is simply 1. No? Derivative ng x plus 3 ay 1. Yan. How about yung derivative ng 2 raised to x? Yan. Again, ln a. Yung a natin is yung 2 multiplied by 2 raised to x multiplied by derivative ng x is also 1. Yan. So, substituting, meron tayong ln 2 and then 2x plus 3. Yan. And then here is ln 2 and then 2 raised to x. Yan. So, getting the determinant, the Wronskian. Ipot ko lang to dito. Okay lang. Yan. Dito. Okay. So, getting the determinant, this will give us getting the determinant of this will give us 2x plus 3 multiplied by ln 2 raised to x minus 2 raised to x ln 2 and 2 raised to x plus 3. No. Which, now upon investigating, from the looks of it, are just the same, no? ln 2 and 2 raised to x, and then 2x plus 3. Meron din ito, 2x plus 3. Meron din ln 2, and then meron din 2x. Therefore, the Wronskian, this is equivalent to 0. Therefore, the Wronskian of 2 raised to x plus 3 and 2 raised to x is equal to 0. What's our conclusion? Therefore, it is linearly dependent. Yan. Since siya ay equal to 0. So, napaka-helpful ng Wronskian, ano? It can determine if it is linearly dependent or independent. As I've mentioned already earlier, what we are actually interested in is to figure out if they are independent, no, or not. Kasi kung independent sila, kagaya nitong mga nakuha nating una, ibig sabihin, ito yung fundamental set of solutions ng isang differential equation. Okay? ma-verify natin na they are solutions of the differential equation if we do the Wronskian on them. Okay. And if they are independent, then they are the fundamental set of solutions. Okay? So linearly independent, and then yung last example natin is linearly dependent kasi equal siya to 0. Alright? Okay. So this brings us to the fourth theorem for our theory of solutions for homogeneous second-order linear differential equations with constant coefficients. This theorem states that if we have y1 and y2 as two linearly independent solutions of the homogeneous equation y double prime plus p of x y prime plus q of x y equals f of x on an open interval I on which p and q are continuous, if y is any solution whatsoever of the equation above on I, then there exists a number of C1 and C2, exists number C1 and C2 such that y equals C1, y1, and C2, y2. And this is for all x in that interval I. So by this time, we can already be comfortable on this concept of the general solution of homogeneous equation. In essence, ang sinasabi lang nito, this theorem tells us that when we have found two linearly independent solutions of the second-order homogeneous equation, then, ito na yun. We have found all of the solutions in that equation. In other words, the fundamental set of solutions. We therefore call this the linear combination y, which is the general solution of a differential equation. Okay? So, please take note of this. Huwag niyo kakalimutan. Y equals C1, Y1 plus C2, Y2. This is the homogeneous solution of the differential equation. Okay? At magagamit natin siya kasi related siya doon sa non-homogeneous. Okay? That this will be an upcoming topic. Now, to summarize it all, suppose we have y sub 1 and y sub 2, and they are found to be solutions of a homogeneous second-order linear differential equation. We can therefore say, kapag ka itong y1 and y2 ay solution, we can say na, number 1, yung Wronskian or yung determinant ng two solutions ay not equal to 0. Okay? So, kapag ka linearly, and if it is not equal to 0, ibig sabihin, y1 and y2 are linearly independent. And if they are independent, it means that they are part of the fundamental solutions. At kung sila ay fundamental solutions, then the general solution is y equals C1, y1 plus C2, y2 of the equation. Right? So I hope you found this summary to be to make some questions clear. No? All right. So this is our problem set 15. We have two items, number 1 and number 2. Okay, that ends my presentation. As Lasalians, let us respond in prayer and say, I will continue, O my God, to do all my actions for the love of thee. Saint John Baptist de La Salle, pray for us. Live Jesus in our hearts forever. In the name of the Father, the Son, the Holy Spirit. Amen. Thank you for watching and see you again in the next topic. Bye.